So I'd like to demonstrate how to do isodose correction for missing tissue, air gaps, or extra tissue. This will be a demonstration of what the assignment you're supposed to complete regarding the 2/3 shift. Okay, so I'm going to start with the contour that I've taken, and I want you to do your 2/3 shift assignment on the contour that you took of your patient. It's not necessary for you to draw internal contour structures, just only to have the external contour drawn. So as you can see, the external contour in this head area is not flat. It's not even. There are a lot of areas in the head that are uneven, that show curvature. And so as we were learning about isodose lines, like this one, or an isodose chart, that gives you a visual representation of what the radiation does when it enters tissue. And these are made by irradiating a water phantom, which is flat. We put the isocenter at the top of the water in the phantom, and then various measuring devices along the central ray and across the beam. And then we take dose measurements and connect points of equal dose along the beam and across the beam. So each of these lines represent a percentage of dose, but again, this represents what radiation looks like on a flat water phantom. So on our contour, which is not flat, where we're going to demonstrate the shift technique, and we're going to use the 2/3 shift, and that's a principle that says that dose lines are going to shift 2/3 of a way when you are using a low energy beam like cobalt. So I have a light box here, makes it easy for us to see. So I'm going to choose a location to put my beam on. This could be any location. In this patient, I'm coming from the AP view. I could put it here, and if I put, again, the T-bar needs to go at the beginning of tissue. You see on this side of the beam there's missing tissue. On that side of the beam there's missing tissue. There's an air gap. If I put the beam here, again I have to put the T-bar at the beginning of tissue. Then I have missing tissue on this side of the beam. I also have missing tissue or an air gap on that side of the beam. You can select wherever you want on the contour to put your beam to do the shift technique, as long as the contour is not flat. So for example, this area of the contour is relatively flat. So when I put the T-bar against it, it looks really parallel, so we could expect that the lines will not shift much. So for this exercise, what I'm going to do is I'm going to put the beam over here right through our tumor. I have a tumor here, and I'm going to decide to put my beam approximately through the center of the tumor. So I'm going to make a dot there. You could extend that and create a central axis if you want to. Okay, so my beam is going to come through the center of the tumor. So again, I'm going to put the T at the beginning of tissue. I want to make sure the central axis that's on the isodose chart goes right through the central axis that I've designated through my tumor. Where I put that dot, I made that X, I have to make sure this goes right through that. And then I'm going to begin to trace the isodose lines. First, I'm going to start by tracing the T-bar, and then I'm going to trace the central axis, and then I'm going to trace each of the dose lines. The 100% dose line is just flat. The 90% dose line is here. You can trace it all the way over if you like. Although each of these dose lines represents absorption and scatter, so outside of the tissue there's really nothing happening, but we need reference points for this exercise. So I'm going to trace each line. Okay, fast forward. I've already done that ahead of time, so I can show you what that looks like. So after I've traced each line, then this is what I have. There's the T-bar at the beginning of tissue. This line represents 100%, and each of the dose lines I've drawn here, I've labeled. Okay, so if this patient's contour were flat, this is what the dose lines would look like coming through the contour, but the patient's anatomy is not flat. So what I'm going to do then Let's get my isodose chart again, line it up again where I traced it, make sure that I have everything in line. This really makes this easy when you have a light box. Making sure I have everything in line. Okay, and I'm going to use the grid lines that are on the isodose chart to help me decide where to measure my shifts. So I could use this grid line if I want to. I'm going to just draw a line from the top of the T to the beginning of tissue, and I could use this grid line if I want to. Draw a line from here to the beginning of tissue, and this grid line from here to the beginning of tissue. And I can number these if I wanted to. 1, 2, 3. Actually take your centimeter ruler. I don't have a centimeter ruler here with me. I actually have my sewing tape, but I'm going to measure this segment, that segment, and that segment. You could even create a sub-segment if you wanted to. Maybe I could create a segment between these two segments. Just have to make sure you draw a straight line. It'd be nice if you had a ruler. So I could now just maybe make dashed lines along this grid line all the way through the contour. Make dashed lines through this grid line all the way through. And if I want to correct on this side, I could make dashed lines through this grid line. And if I'm going to use this sub line, this one that I would create between this one and that one, I could make dash marks all the way down there. You know, these are just going to be reference points from which I'm going to measure. Alright, I'm going to switch paper because I've already done this. I'll show you what it looks like.